my dear friends, welcome to my YouTube channel. This is Stanley and you are watching Study with Stanley. Today we are going to study about the lesson States of Matter. Before we delve into today's content, first you should know what this topic tells to us. If you see this topic, it is of two parts. The first one is states and the second one is matter. My dear friends, if I ask someone what is matter, they will tell the classical explanation, that is, matter is something which occupies space and has mass. Let me write it here. Matter is something which occupies space and has mass. This is absolutely correct. But as a student who is preparing for competitive exam, your explanation must be somewhat better than a 6th grade student. So, my dear friends, let me make it more clear. If something have a mass, it should have something inside of it, no? If a matter have mass, how this mass came to this matter? To know that, we need to understand the fundamental arrangement of this matter or the constituent particle of this matter. This matter is made up of a most fundamental particle which we called quark and lepton. Let me write it here. Most fundamental particle. What are they? They are quark and lepton. This quark and lepton combine to form atom, and this atom combines to form, which means two atoms combines to form molecule, and this molecule, two or more molecule combine to form matter. So my dear friends, from this moment you should change your explanation about matter as matter is something which is made up of quark and lepton, which combine to form atom, and those atoms combine to form molecule, and that molecule forms this matter. So we can see about the second part, and that is states. In this whole lesson, the word states defines the physical state of this matter. Let me write it here. Physical state of this matter. What is this physical state? The state which is defined by the physical properties. You may be wondering what is a physical property, but no problem. If I give some example, you will clearly understand it. I will write it here. It is defined by the physical property or properties. What are they? The best example is mass, volume, density, color, etc. So my dear friends, what are these properties? Can I say whatever the properties you are observing through your eyes are these properties only? So can I write these physical properties as observable properties? Yes, that's absolutely correct. I can write this physical property as observable properties. So whatever the properties that you are observing through your eyes are called as physical properties, and the state which is defined by those properties are called as physical state. So my dear friends, now you have a clear idea about what is state and what is matter. You may be wondering what are the type of the state. That is our next topic that we are going to discuss. Let me write it here. There are almost 22 type of states in this world, because each and every day new states are being invented. But till now we have 22 types of states. So in this 22, we need to learn only about 4th state, because 4 states, they are the major state that is used in our textbooks. So what are those 4 states? I will write it here. The first state is solid, second is liquid, third is gas, and the fourth is plasma. So these 3, which are solid, liquid and gas, are very familiar to you, but this plasma is somewhat new to you. So I will explain this plasma here. This plasma is formed when a substance is heated at a very high temperature. Let me tell it as superheated. I will write it here. The substance is superheated. So when a substance is superheated, it forms a cloud of charged particles. What are charged particles? They are electron, proton and various other charged particles. The main condition of this plasma is when a charged particle is moving, it produces a high magnetic field around it. So if you see this plasma, you need to remember that these 3 points. What are they? The first is, it is formed when the substance is superheated. And the second one is, it is a cloud of charged particles. What are those charged particles? They are electron, proton and etc. When these charged particles are moving, they produce a magnetic field around them. The best example for this plasma is lightning. When during the raining season, you can see lightning. During those time, it is a type of a plasma, because lightning, it creates a high heat. Due to that, the atmospheric particle will become a cloud of charged particle, because those substances are being superheated. So it forms a plasma. So the best example for plasma is lightning. So my dear friends, you will get clear idea about what is solid, liquid and gas in upcoming sessions. In this lesson, we will concentrate more about the gaseous state and a little amount of liquid state also. About this liquid state, you will study clearly in your physics, that is mechanical properties of liquid. So this states of matter will concentrate mainly on gaseous state, and about this solid, we will study a separate lesson which is called as solid state. Okay. After studying all these things, you may be wondering how this type of states are formed. So my dear friends, all this type of states are formed due to competition between two forces. Let me write it here. So first I will erase all these things. All these states are formed due to a competition between two forces. Due to competition between two forces. What are those two forces? The first one is force of attraction. We can also denote it as FOA. This force of attraction will make the particle to be close to each other. let me write it here. This force of attraction makes particles to be closer to each other. Like it will pull the neighboring particle towards it to form a bond, or to be close enough to form a close, structure, closed structure. And the second one is repulsive force. As we studied in force of attraction, the force which makes the particle to be closer to each other, in the repulsive force, this will make the particle to move far from each other. This repulsive force will move the particle, which means the neighboring particle, to away from its own particle. So this will increase the distance between the two particles. That particle may be atom or molecule, anything. So this will increase the distance between the two particles. So about this force of attraction and repulsive force, we are going to study these two in a detailed manner so that you can easily understand everything. First, I will explain about force of attraction. When we are studying about this force of attraction, there are two types of force of attraction. I will write it here. It is of two types. The first one is intramolecular force, and the second one is intermolecular force. This intra and inter, you know very well before itself. This intra means within, and inter means between. This intramolecular force defines the bond between the atom in a molecule, which means this force is denoted for the atom which is present inside the molecule, and this force is called as the force between two molecules. So if we see in a beginning itself, we saw how this matter is formed. It is formed as quark and leptons, atom, molecule and matter. So this intramolecular force denotes the force between the two atoms which combine to form a molecule, and this inter denotes the force between two molecules which combine to form matter. This intramolecular force denotes that bond. What are the type of bond we have in this intramolecular force means? The first one is ionic bond, and the second one is covalent bond. The best example for ionic bond is NaCl, your table salt. We can write this NaCl as Na plus and Cl minus. Because of transfer of electron, we form this ionic bond. And covalent bond, the best example is H2, Cl2 and etc. So the main thing is this intramolecular force is very much stronger than this intermolecular force. Why? Because this ionic bond and covalent bond are very strong than this intermolecular forces. This bond is since it is very much stronger than this intermolecular forces or the bond formed due to this intermolecular force, there are various conditions occurs here that I will discuss in just few minutes. Okay, wait for a few minutes. I will teach a condition which satisfies this, which tells you clearly about this ionic bond and the strength of this intermolecular force and the intramolecular force. Before that, we will get a clear idea about this intermolecular force. As I said you before, this is a force between two molecules. The various examples are van der Waals force. What are the example for van der Waals means? The first one is dipole, and second one is dipole induced dipole. Third one is dispersion force, or London force. And the various other examples are hydrogen bond and the dipole ion, dipole induced ion, and the various. So from this topic itself we can understand this intermolecular forces are very weak when compared to intramolecular force. So that is an important question in competitive exams. It is a type of assertion and reason. I will write it here so that you can understand that. Okay, I will erase it. That question will tell us about that ionic compounds. So everyone is thinking like ionic compound is a normal compound as like a covalent compound and the properties will be similar. But it is not true. Ionic compounds are really different than covalent bond. Okay, I will write that question here. Ionic bond, ionic compound, whether contain intermolecular forces or not. So this question tells like whether ionic compounds have a intermolecular forces or not. My dear friends, to answer this question, you will understand the first condition. In ionic compound, that compound is formed as a ionic crystal. That is the first thing you need to understand. That ionic compound are formed as ionic crystals. Then the constituent particles are arranged in ionic lattice. So, as I said you before, this intermolecular force is a very weak force. It can't hold that ionic molecule together for a very long time. So, this ionic compound will never have a intermolecular force between them. So, whenever you get this question, you should think properly and you should understand these two compounds, two conditions. The first condition is ionic compound is different from is formed as an ionic crystal, which is different from covalent compounds. The second one is the constituent particles are arranged in a ionic lattice. So my dear friends, you should never do mistake in this question hereafter, because this is a very frequent question as in competitive exams which students are continuously making mistakes. I never want you to make a mistake in this question again. And the second force we need to study is a repulsive force. So repulsive means what they used to do is they will increase the distance between the two constituent particles, which means between two atom or molecule. The second one is a repulsive force. So the major reason for this repulsive force is thermal energy. To understand this, you should know an equation which is known as kinetic equation of gases. You may be wondering how that equation came. Don't worry, in second or third part of this lesson, I will teach you in a detailed manner how that equation came. Now, you just understand or memorize that equation and you need to understand how that final equation came. So, I will write it here. That equation is known as PV is equal to 1 by 3 N M V square. Here, P represent pressure, V represent volume, this N represent number of moles, and this M represent a mass, and this V represent velocity. So my dear friends, if I multiply and divide this right hand side with the 2, what I will get, I will write it here. I just multiply and divide this with the 2. I will get this equation as like this. Can I separate this part? PV is equal to 2 by 3 into 1 by 2 M. Okay, I will write it a capital M V square into N. This PV from an ideal gas equation, this also I will teach you, don't worry. This is an ideal gas equation. Ideal gas equation, PV is equal to nRT. From this equation, can I substitute that nRT instead of PV? Yes, I can do that. nRT is equal to 2 by 3 into what this 1 by 2 mv means. That is the kinetic energy. So, or we can tell this kinetic energy as translational energy also. We can write it as E is equal to half m v square. This E represent kinetic translational energy. So I just substitute that as E into N. Can I cancel this N on both sides? Here this R is universal gas constant. I will write it here. It is universal gas constant. So it has a constant value. Here can I equate this E and T, because this 2 and 3 also are constant. Thus E is directly proportional to T. From this equation we get a conclusion that E is directly proportional to T. When I am increasing a temperature of a gas, its energy will also increase. Yes, absolutely, I can tell it, because it is directly proportional. From this equation, can I tell when energy is increased, its velocity is increased? Yes, when energy is increased, when temperature is increased, its energy is increased. When energy is increased, its velocity is increased. So, when velocity is increased, its distance will increase. Am I right? Yes. When velocity is increased, its distance will also increase. This distance is what the distance between two constituent particles, which is atom or molecule. So this repulsive force, it's directly depends on the thermal energy or the temperature. I will repeat it again. When temperature increases, its energy is increased. When energy is increased, its velocity is increased. When velocity is increased, its distance is increased, so that the molecule will repel each other. So, after studying all this, you should know how these two forces contribute to the formation of states, no? That is what our next thing is. Let me erase all these things first. So the three major states that we studied is, first one is gaseous state. In this gaseous state, this repulsive force, I will write it here, repulsive force is greater and greater and greater than force of attraction, so that this gas molecule is expanded, it is moved everywhere. It won't have a definite shape or it won't have a volume. And the second thing is liquid state. Here, this force of attraction is greater than a repulsive force, but it is not that much stronger than this repulsive force, so that it doesn't have a shape. So if you fill this liquid in a bottle, it will take a shape of that bottle. In a vessel, it will take the shape of that vessel. And the third one is solid state. Here, this force of attraction is greater and greater than a repulsive force. Thus, it have a definite shape. As you see, all solids have a definite shape. That's why we call it as a solid state. So my dear friends, now you can understand how force of attraction and repulsive force contribute to the different type of states. In this three state, we study only about gaseous state. You may wondering why we are studying only about this gaseous state. But before we are studying about the gaseous state, you should know what are the gaseous elements in the periodic table that is being in the gaseous state in its natural configuration. Okay, I will write it here. There are totally 11 elements in periodic table exist as gaseous elements. So what are they? I will write it here. It's a first group and we will write it as 80, 70. Okay, I will write it from here. First we will write hydrogen and here helium and all the noble gases, because they are gases: helium, neon, argon, krypton, xenon, radon. And then second one is fluorine, chlorine, and here is nitrogen, oxygen. We can count it here: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. Now we can write it is a first group, it is 18th group, it is 17th group, it is 16th group, it is 15th group. So These are the 11 elements which exist as gaseous elements in their natural state in the periodic table. So my dear friends, you should first understand, you should remember this, all these elements, because these are the elements which exist in gaseous state, and we are studying about the gaseous state of a matter. You should first know what are the elements which are in gaseous state. It is very important. I hope you may note this, you may remember all this element afterwards. And the next thing is, we have all the states, but we are studying only about gaseous state in an elaborate manner. Why we are studying only the gaseous state? That is what our next topic is. Why we are studying only gaseous state. The first reason is, the gas, it has infinite expansibility. This tells us like we can expand it to any extent, because gas molecules, it doesn't have a no strong force of attraction, doesn't have a perfect shape, so we can expand it to an infinite length. And the second one is, it is highly compressible. Like if you take a balloon and you fill it with a gas, you can press it till it bursts. No? So that we can tell that gas molecules are highly compressible. You can't compress a brick like that, but you can compress a balloon which is filled with the air to any extent of compressible. So the third one is, it exerts equal pressure on all sides. So I can explain this with a diagram. If you take a container and you fill it with the gas molecules, these are the gas molecules. If you calculate the pressure which is exerted on the top of this container, the bottom and the right and the left, all this pressure will be equal, because gas exert equal pressure on all sides. And the fourth one is, when we mix gas, when we mix two gas, it will completely mixed with each other. Why? Because if we mix two gases, it will mix completely and you will get a uniform mixture. You can't separate two gases. Like if you mix oxygen and carbon dioxide, it will appear to you like a individual, a single gas. It won't show any difference between themselves. So we can say this gas is evenly mixed with each other. So these are the four things which help us to which make us to study about this gaseous state in a very elaborate manner. So my dear friends, thank you for spending your time for watching my videos, and please do subscribe and share this video with your friends. Thank you. Have a nice day.